I think on Sunday, about the introduction of about our GPIO uh, architecture and how we are going to basically establish the connection with your APB interface. Okay, so what are all the components which we are going to have? What is the architecture of our GPIO? Those and all things we have seen, right? Yes. So let us start this session. In this particular session, we will try to understand how we are exactly going to develop the Verilog code for whatever the architecture we are going to have. Okay. So let us start with that particular discussion. So I hope my screen is visible, right? Yeah. So this is what we are going to have. This is our top module, which is basically GPIO top. Okay. So this GPIO top is going to have this particular signals, the APB interface signals it is going to have. So what are the APB interface signals it is going to have is P clock, P reset, and I hope you're all aware of APB interface protocol. So if you're not aware, then this discussion will be a difficult one to understand. So I recommend you to please go through the APB protocol, which is also available on our channel, right? Now, so this particular top module is going to have the interface signals as P clock, P reset, P address, P select, P enable, P write, PW data, and all the APB related signals. So let me draw that particular thing in the slide. So I'm going to have my APB top module. So this is my APB top module which I'm going to have. So the name of this is APB underscore GPIO underscore top. APB underscore GPIO underscore top. So this is going to have the signals. Let me show them. So which is P clock, P reset N, and what else we have? P address, P select, P enable, P address, P select, and P enable, P write, P enable, and I have P write signal, and also the PW data is also input. So we are going to have the input as PW data. Since this is APB based GPIO underscore top is nothing but it's a slave, right? Okay. So this is slave. That's why these particular inputs, these are inputs, and PR data and P ready are our outputs. PR data and P ready is also an output to our top module. And we have an IO port, which is nothing but our expense. Okay. So this is basically going to communicate with your GPIO pins, external GPIO pins. This is our input output port. Okay. And another is output IRQ, interrupt handler, which is IRQ. Okay, which is an output. So these are my inputs and outputs and in-out pins of my APB GPIO underscore top. Now, this APB underscore GPIO top is going to have few internal signal, internal modules. Okay. The very first module which we are going to have is GPIO controller. So this particular top module is internally going to have the top modules like this. So this is our APB GPIO top, and this is internally going to have one module which is nothing but uh, what is this module name? GPIO controller. I've named it as GPI underscore controller. Okay. And next we are going to have something known as GPIO port interface. So we are going to have one another component as GPIO underscore port underscore interface. Okay. So this is basically to handle your expense. Okay. And next we are going to have one more is GPIO underscore interrupt. GPIO underscore interrupt. I'm spelling it as INTR. Okay, that's it. So these three modules we are going to have. And whatever the registers we have discussed, right, that will be present inside your GPIO controller. Okay, the registers will be present inside your GPIO controller. According to this register configuration which we are going to do, we are going to decide the direction whether we are going to write into the X pins or we are going to read from this pins. Okay, depending upon this direct register values we are going to decide. Okay, so this is what we are going to do in our code, and we need to test this APB GPIO top, right? For this we are going to write down a test bench. Like this, we need to write down a test bench for testing our design, and this design is internally containing three models that we need to instantiate in this particular APB GPIO top. Okay. Is it clear, guys? Up to here, any doubts or any queries in this? Yeah, it can be anything. It may be a bridge or it may be anything. Master can be anything. It may be a direct connection to the processor, or it may be a bridge, or it may be a module with APB interface. Okay. Others also, is it clear? Any doubts or any queries? Shall we move forward? Okay. Now, now let us try to discuss one by one. Like, let us try to understand one by one model in great detail. So first, let us try to have the discussion of our GPIO port interface. Okay, let us try to understand what do you mean by this GPIO port interface. So first, let me draw the block diagram of this particular GPIO port interface. So this GPIO port interface, this is my GPIO port interface. So it is going to have one of the signal as P clock. So this is the clock reference we need. And another is P reset N, which is active low reset we are going to have. What happened to this? 1 minute. Yeah. So we are going to have P reset N, and one more signal for this is GPIO direction. Okay. GPIO underscore direction. Okay. And another input is GPIO data out. GPIO underscore data out we are going to have. And the output of this is GPIO data in. GPIO data in. So these are the signals which we are going to have. The output of this is GPIO data in, and another is expense. So these are my inputs and outputs of this GPIO port interface. Now, we already know this clock is just a reference. It's a sequential circuit, right? We need a clock for synchronization, and P reset is for resetting your pins. And this is very important. GPIO direction. Basically, this GPIO direction will tell you whether you are going to write into these pins, that is from master. This is my master, right? From master to this GPIO controller, to my output expense I will have, right? So if you are going to write into this expense via this GPIO controller, or else you are going to read from this pins. Okay. So this direction is going to tell you whether you are going to write into this pins or whether you are going to read into this pins. This is going to tell. Now, if you are going to write into these pins, you need to get the data right from the master. That is what you're going to get from here. Using the GPIO data out, you're going to get the data to this particular module so that you can write it into this expense. Okay. And let's say if master wants to read the data. Okay. Like, let's say if the master wants to read the data from this GPIO pins, so we are going to give that data using this particular pin. This will be connected to your master side. I will show you where it is connected exactly. Is it clear? The pins description, is it clear? Yeah. Yes. So this enable is GPIO direction. This will act as your enable pin. Okay. So mm, So basically, GPIO data out is a signal which we are going to get from the master side. Okay. And let's say if the master wants to get the data, that particular signal we are going to give it from GPIO data. So that is the architecture which I've shown you previously is just for understanding. But when we are developing the code, we can add some more extra signals for us for our convenient. Okay. Yeah, exactly. Yes, yes. Okay. Yeah. Others, any other queries? The pin descriptions, are they clear? That I will show you. Yes. Yes, yes. So I'm coming from the lower level module. So I'm coming from the right hand side to left hand side. Okay. Yeah. So let's see the code for this. So I've declared all the inputs and outputs for this particular module. Next, using a generate for loop. So I have 32 pins. So in this particular architecture which I took, so I'm basically considering that I'm going to have 32 number of GPIO pins. Okay. So using a generate for loop, I can generate this particular thing. And if my GPIO direction is equal to 1, so whatever the data which I'm going to get, so this GPIO data out is input, right? So that particular data will be given to this expense. That means whatever the master is driving, that will be given to this expense, or else we are going to drive high impedance. Okay. In last session also we have seen a tri-state buffer, right? So if our enable is equal to 0, that will be driving impedance, high impedance value onto its pins, or else it is going to drive whatever the data which we are going to get it from the master. Okay. Is it clear? That's it. And so next, if we want to read the data, then at passage of clock, whatever the data we are going to get it from the expense, that we are going to give it to GPIO data in. Okay. This will be given to your master. Okay. And this is getting from our master and this is giving to our master. How we are getting and how we are going to give, that we will discuss in our GPIO controller. Okay. Up to here is it clear? That's it. This is the code for our GPIO port interface. Any doubts or any queries in this? Yeah. Yes. We have given to GPIO data in, but from this GPIO data in, whether we are going to give it to the master or not, that is going to be controlled by our controller. Here we are just giving. Okay. From this GPIO data in, how we are going to give it to master and how we are going to control, that is the work of our GPIO controller. Okay. The port interface, it's just going to pass the data. Yeah. And any other queries, guys? Okay. Now let us see the next one, which is our GPIO controller. Okay. So coming to my GPIO controller, which I'm going to have, these are the inputs you can see. So the P clock, P reset and P address, P select, P enable, P write, PW data, PR data, and P ready. These are all my APB interface related signals. Let me write it down. So coming to my GP, sorry. Have you watched the previous sessions on GPIO? I posted the recordings in the group, right? Okay, once please go through them. We had a great detailed discussion on GPIO related things, right? Okay. Yeah. 1 minute. What happened? This is not responding. Yeah. So coming to my GPIO controller. 1 minute. What happened to this? So coming to my GPIO controller, which I'm going to have. So this particular block diagram is going to have APB interface with it. I'm not writing all the signals. So it is going to have the APB interface signal. And also this is going to have, apart from the APB interface signal, it is going to have GPIO data. You can see it. This we are going to get it from the interface. Where is it? I think I have closed it. Let me open it. Yeah, this one. So whatever the GPIO interface is giving, right? GPIO data, and you can see, right? This is going to given to our GPIO controller. This particular signal that will be connected. Where is it? Yeah, this one. Okay. So this GPIO data in GPIO underscore data in. Okay. So this we are getting it from GPIO interface. GPIO INTR. What is the signal name exactly? This particular signal GPIO data in, we are going to give it to our GPIO controller. Okay. And next is interrupt status in, that we are not going to discuss now. Interrupt, first let us try to have a basic establishment of how it is working. Next we will discuss one by one. And next is output GPIO direction. So this is GPIO direction is a output signal which is being basically given to our GPIO interrupt module. Okay, you can see over here at GPIO direction. This signal is basically given by our GPIO controller. Okay, and next is interrupt status in. This is also output, and it is going to given to our interrupt module, which we are going to have. And next is GPIO data out. Okay, so this is also given to our this particular signal GPIO underscore data out. So whatever the signal which we want to drive to our output pins now, that we are going to give it to over here. Okay, so whatever the signal which we are going to get it from our master via the APB interface, right? So that particular data, if we want to drive it to our GPIO signals via the GPIO interface module, that we are going to give it via this particular signal, which is nothing but our GPIO data out. Okay, and next is my GPIO interrupt underscore enable. For enabling my interrupt, that I'm going to have as my output GPIO underscore interrupt underscore enable. Okay, these are the inputs and outputs of my particular module, right? So any doubts or any queries in this inputs and output signals of this particular module? One minute, and give me 1 minute. Hmm. 1 minute. Yeah, sorry for that. There was some disturbance. So is it clear? Any doubts or any queries in this? Yeah, I hope these are clear, right? So let us see the internal structure of code what we are going to have. So you can see I have declared three registers. One is direction register and another is for holding our whatever the data which we want. That is data out underscore register. And next is interrupt enable register. Okay. So I have three registers which are present, and this particular registers are assigned to my output pins. So that direction is basically given to assigned to direction register or direction pin, and next data out register is assigned to data out pin, and interrupt enable register is assigned to my interrupt enable pin. Okay. Now, so I've made my ready signal period is equal to 1. I'm not adding any delay over here. And so I've declared the four parameters over here. One is address underscore data out, which is declared as 00. And for direction, I'm taking the parameter as 4. And data in, I'm taking as 8. Interrupt enable is C. And interrupt status is 10. Okay, 10, sorry. So if I want to drive any data, what is the address I need to provide is 00. Okay. And if I want to access the direction register, the address I need to provide is 4. And if I want to uh, read the data from the GPIO pins, I need to give the direction as 8. Okay. And for interrupt related signals, I need to provide the addresses as C and 10. Okay. So I've declared these parameters. So if you're going to provide this particular addresses only, you can perform this particular operations. Okay, how we are going to perform, I will show you. Okay, so this is for driving GPIO pins, for driving GPIO pins. Okay, if you want to drive the GPIO pins, you need to provide this address. This is address for this address for driving GPIO pins, and this is for deciding the direction of GPIO pins, whether you want to write or whether you want to read. Okay, deciding the direction of GPIO pins, and this is for reading the GPIO pins data, reading from GPIO pins. Okay, and this is for status registers. Okay, and sorry, interrupt registers. Okay, yes. And coming to my state parameters, which is idle, setup, and access. So in APB interface, we will have three phases, right? So idle phase, setup phase, and access phase. And I'm going to take two state registers, state and next. Okay. And this is my reset logic. If I am going to apply reset, which is active low reset, I'm going to idle state, or else I'm going to next state. Okay. And next is my combinational logic. Next state is a combinational logic. So if you have observed in APB protocol, also have used the same state machine. So if my p select is equal to 1, which is made by my master, I'm going to setup phase, or else I'm going to present in my idle phase only. Okay. And in the setup phase, if my enable is made to 1, I'm going to access phase, or else I'm going to stay in the setup phase only. And in the access phase, I'm going to idle phase. Okay. And by default, I'm going to be idle phase itself. Is it clear up to here? Any doubts or any queries? Okay, that's great. Now, next, what I'm going to do is I'm going to write my write logic. So I'm basically performing the write operation at the passage of clock, or else it's an asynchronous reset. So if I'm going to apply the reset, then my direction register will be equal to 0, made to 0. The data out register is also made to 0, and interrupt register is also made to 0. Now, if I am in access phase, or else uh, if I'm in access space, then and also my p rate is equal to 1. So why I'm basically checking for access spaces? The access phase is a phase where your slave is going to sample the data. In this phase only, your slave is going to sample the data. That is why I'm having my state checking at access phase, and p rate if it is equal to 1. That means my master wants to drive the data to the GPIO pins. That's why p rate is equal to 1. Okay. Now, I'm basically taking the address. So if my address, if it is equal to 00, that means I want to write the data. Okay. I want to write the data into my GPIO pins. Now, what is address underscore data out? It is equal to 0. So if you're going to provide 00, then you're basically going to write the data into GPIO pins. Now, if a software person or an embedded person, if we want to write the data into GPIO pins, this is, let's say, this is some model which we have developed, and if we want to write the data into this GPIO pins or interface, then he need to provide the P address as 00. Then he is going to access the which register he is going to access the data out register. Then he is going to access the data out register. This data out register address is 00. The last 8 bits should be equal to 00, so that he is going to access this particular register. Okay, he is going to access this register, and he is going to store the data whatever he want to write, that will be stored inside over this particular register. Now, let's say if he wants to set the direction of your GPIO pins. Okay, so if the GPIO pins, if we want to set the direction as output, okay, that means your the data will transfer from master to pins. Okay, this is nothing but my write operation. If we want to make, then the direction should be equal to 1. Then the direction register should be equal to 1. Or else if we wants to read the data from pins to master, then the direction register should be made to 0. This configuration he need to make. Okay, now there is one register which is known as direction register. This is my register which is direction register. And if you want to update or configure this particular value, what is the address you need to provide? You need to provide the address as 4. Okay, so if you want to access this register, you need to provide the address via this p address as 4. The last 8 bits should be equal to hexadecimal 4. Okay, so that you are going to configure you can configure this particular data direction register. Okay, now if you are going to configure this direction register as 1 1, or let's say FF, then you're going to provide the particular direction as or whatever the direction pins. Like, let's say suppose we have 32 number of pins, right? We have 32 number of GPIO pins. Let's say this first pin, if you want to make it as 1, then you need to provide this particular pin related bit as 1. And let's say if you want to make all of them as 1, then you need to provide all this particular register contents as 32-bit 1. Or else, let's say suppose if you want to make first pin to output, second pin to input, third pin to output, then you need to provide then you need to configure this register as 1 0 1 followed by 1, and if you want to make the another register as input, you need to make it as 0. So like that, you need to configure the register content. Okay, if you want to access the register, you need to provide this address. And if you want to decide what pin should work as, like if it want to become an output, you need to provide that particular value as 1. Like let's say suppose here we are accessing, or we are configuring 1 2 3 4 5 6 pins, 6 pins we want to configure. Then what is the register content that should be present is 1 0 1 1 0 1. This is what the register content should be present, so that you are going to perform this particular operation. I think it is clear, right? Yeah, so this is what it is happening. Yeah, sure. Exactly. 32 bits. It's a 32-bit data bus. Yes. Okay. Yeah. So I hope 32 different pins. Yeah, exactly. Yeah. But let's say if you're not going to give the direction for other pins, then it is not being configured. Okay. Yeah. Others also, is it clear? Any doubts or any queries in this? So after writing this particular code and all, actually what happens is you need to prepare a document, and this particular document will be given to the software team or the embedded team. So they will be looking into the addresses of each and every register, and they are going to configure the register as what we have provided. So we are only going to decide the address of each and every particular register we are going to have. So yeah, exactly. So they are going to basically decide. They are going to refer to the document which we are given, going to give the specification we are going to give. Accordingly, they are going to provide the contents of that, and they are going to configure the registers. Okay, and this will be very interesting concept if you know UVM. So in UVM, we are going to use the RAL concept, register abstraction level concept, and we are going to mimic this particular behavior, and using front end and backdoor access, we are going to configure our registers. And if possible, I will also plan that particular workshop in future. Right. So this is about our direction register. And next, let's say if you want to access the data, if my master wants to access the data from the GPIO pins, it is going to use something known as PR data. Okay. No, no, no. I think where we are left with, yeah, this one. Yeah, we were discussing about this, right? Yeah. And let's say suppose if my master wants to access the interrupt enable register, then it is going to provide my address as this particular thing. What is my address for this is C. Okay, it's hexadecimal C. Okay, so it is going to provide this particular address so that we can able to access this particular register. Okay, so accordingly, if you want to access which particular register, you need to provide the address of that particular register. Then only you can configure that register. Configure in the sense you can provide some value to that particular register. Okay, so let me once again clarify this. So we have three type of registers. One is for storing your data. If you want to write any data into your GPIO pins, if your master wants to write any data into your GPIO pins, it is going to basically first access this particular register. If you want to access this particular register, and if you want to store any data into this particular register so that your data will be written to the output, you need to provide the address as 00 via the p address. Via the p address, you need to provide the address. Okay, who is going to provide? You can write down a C program for that. By a processor, it is going to provide it. Okay, next, if you want to decide the direction of this pins, whether it is output or whether it is input, if you want to provide it, you need to configure this particular register, which is of 32 bits. This is also of 32 bits. Okay. You need to configure. For example, we have pin number 1, 2, 3, so on to 32. And if you want to make pin number 1 as an output pin, then here the LSB bit should be equal to 1 so that this pin 1 will be output. Let's say suppose this pin number 2 should be an input. Then what you need to make, the second bit should be equal to 0. Let's say third pin should be an output. Then the third bit should be equal to 1. So like this, you need to configure this register. Okay. How to configure the register? I mean, how to write the data into this register is using the address. You need to first of all provide the address. Then you are going to write the data into this particular register. Okay, I'm not going to use a term writing the data into register. I'm going to use a word which is configuring the register. Okay, yeah. So this is what we are going to do basically. Is it clear, guys? Mm. Shall we move forward? Is it clear? Okay, that's fine. Now next, what are we going to do is, let's say if I want to read the data. Okay, so if I want to read the data, I'm going to provide the address as 0. Okay, so address underscore data out. So where is this? Yeah. So if I want to read the data, which I'm going to get it from the GPIO pins, that will also be stored inside my data out. Okay. Now you might get it out from master. If we are going to drive into the GPIO pins, we are going to use the same register. And from the GPIO pins, if I want to read the data, then also I'm going to use the same register. Then what happens? We need to use this direction. So using this particular direction pin, we are going to differentiate between write data and read data. If we are going to make this direction pin as 1, then we are going to store the write data, or else we are going to store the read data. Okay, accordingly we are going to access it. So again, if you let me show you again. So if my master wants to read the data from my GPIO pins, from this first pin, if it wants to read, then first of all what it needs to do is it need to configure this particular register. Then what it is going to do, it is going to read the data from this pin and it is going to access the data via the PR data signal. Via the PR data signal, it is going to access it. You can see in the code also. So via the PR data signal, it is going to access the signal. That is the data GPI underscore data underscore out underscore rich. So where is the signal we are going to get it from? Let me show you. So GPI underscore data underscore out underscore rich. We are going to get it from where is it exactly? Yeah, this particular signal. Sorry, the contents which is present inside this particular signal, that we are going to give it to the PR data. Okay. Next is let's say if I want to know the direction of what is that we have configured. Let's say suppose we have configured the internal registers. This is my internal registers, right? And let's say if I've configured this internal registers, and if I want to check it out, like what I have configured this particular values, if I want to know in a programming level, in a application level, if I want to know that status, okay, then what I'm going to do, I'm going to provide that particular address and I'm going to read that particular content. Okay, so GPI underscore direction underscore register will be given to PR data. Okay, and for reading the data in from my GPI pins, I'm going to provide this particular address, which is 8. Okay, where is this 8? Let me show you. Yeah, so if I want to provide this address, then I'm basically able to read the data which I'm going to get it from my GPI underscore data underscore. Okay, sorry, here this is basically if I want to know the content. Okay, if I want to know the content of the register. Okay, not that if we want to read the data from the GPI pins. Sorry. So basically, what is this is basically if I want to know the content which is present inside what we have written into the register. If I want to read that, then I'm going to provide my address as 0, and from PR data I can read it. Okay. So this I can do. And let's say if I want to, if I have configured my direction register some value, and if I want to know that particular status, then I'm going to provide the address as 4, and from PR data I'm going to read the content. Okay, to know the content of my direction register, know the content of my direction register, I'm going to use it. Now let's say if I want to read the data from my GPIO pins, I'm going to use this particular address. What is this address? Address is equal to 8. Okay, not this one, this one. Okay, so you can see where is this GPIO data incoming from. Let me show you. Yeah, you can see it is an input. Okay, GPIO underscore data underscore in. This signal we are getting it from here. This one, GPIO underscore data underscore in. From expense, we are going to give it to the GPIO underscore data underscore in. The code also we have seen, right? So this will be given to your GPIO underscore data underscore out. From here, you're going to give it to, sorry, where is it? This one, GPIO underscore data underscore in. This you're going to give it to your APB interface signals. Okay, that is what we are doing over here. So if you want to read the data, you need to provide the address. Where is this particular thing? Not GPIO controller. Yeah, this one. So if you want to read the address, sorry, if you want to read the data, you are going to provide the address as 8. Then you can read the data which you are going to get it from the GPIO pins, and you can read it via PR data. Okay. So remember there are three functionalities over here. Okay. Let's say if you are a user and if you are going to use this particular GPIO interface, right? And let's say if you are configuring this particular data register by giving the address as 00 and by providing the data value which you want to drive, and you're also configuring the direction register by providing the address value as 4, and you're configuring the pins. Okay, let's say if you want to know what is the value you have configured this data register, and what is the value you have configured this direction register, if you wanted to know, okay, in the application level, if you wanted to know, then what you're going to do, using the PR data signal bus, using the PR data by providing the address as 00, you're going to look into what exactly you have written into this register, and using the PR data signal only by providing the address as 04, you're going to look into what you have written into this particular register. That is also very important now. Like let's say suppose if you are going to write something, and if something is stored inside the register, that is a problem. Now you need to know. That's why we are using this two conditions. And third condition, third address is 8. If you are going to provide this address, then whatever the data which is being given from the GPA opens, that is being stored inside the register, that you can access it by providing this particular address using the PR data signal. This is what we are doing. Is it clear? Any doubts or any queries? The three operations. Yes. Shall we move forward? So initially it will be little bit confusing unless and until if you open the code and do understand it, then it will be clear. Okay. Yes. Any other queries? Okay. I hope everything it is clear. And regarding this interrupt, we will discuss what is and how it is working. We will discuss. And that was about my GPIO controller, GPIO interface. And I don't want it to start about this interrupt now. So first let us see the test bench of how we are basically writing this. Okay. So let us see the test bench for this. So how we are going to write. So coming to my test bench, and in the top model, just I'm going to instantiate all of them. There is nothing in that. In the top model, I've declared all the signals. Let me check whether I've started the recording or not. 1 minute. Yeah. Okay. So coming to the stop model, I have just declared all the signals which are required, and next I have declared all the internal interconnection wires, and next I have instantiated my controller and the GPIO interface and interrupt signals, and that's it. Only the three modules have instantiated them, right? Let me show you the test bench for this. So in the test bench, I have declared all the signals which are required to instantiate my design. And here you can see in my test bench can also access this expense rate. Okay, so if my address, if it is equal to 0, that means your master wants to read the data from the slave, from the GPA opens. Okay, that is what I'm doing over here. The GPA opens from the slave side, or you can say yeah, from the slave side I'm driving them. Okay, I'm driving the value of AE. Okay, if my P address is equal to 0. Okay, and that is basically given to my expense. This expense will be read from by your master, okay, or else I'm making it to high impedance, okay, and I've instantiated my top model, and next I'm generating a clock. This is all common. Yeah, for writing the data, I've written a task which is basically having an arguments of address and data. Okay. So at passage of clock, I'm going to assign P address as address, P data, PW data as data, P write is equal to 1, P select is equal to 1, P enable is equal to 0. At passage of clock, I'm making my P enable is equal to 1. So after one cycle only, I'm making my P enable is equal to 1. And next, after next cycle, I'm making my P select, P enable, everything is equal to 0. Okay. And next, what I'm doing, this is my write operation, APB write. This is a task. And what I'm doing here, I'm applying my P reset. And after that, I'm desetting my reset. Now I'm going to call the task APB underscore write. And you can see what is the address I'm providing for. So basically, I'm accessing the direction register. So I've told you, right? So 4 is nothing but my direction register. I'm accessing it. And what is the content value I'm providing over here? All zeros FF. That means last 8 pins I'm making them as 1. That means I'm making them to as output pins. That means the master wants to write the data. Okay. So I've configured my direction register. Next, what I'm going to do, I'm going to access my data register by providing the address as 00, and I'm providing the data which is nothing but A. Only the 4 bits of data I'm writing wantedly, and next 4 bits of data is 0. Okay, this is the data I'm writing them. Now, afterwards, let's say if my master wants to read the data, it is again configuring the direction register by giving the address as 4, and it is configuring the direction register as all zeros. That means we are trying to read the data. Okay. Next, and what are we going to do? We are going to access the data register by giving the address as 00, and we are going to give the data out. Okay, here we need to actually give 8. That means we need to give we are basically trying to access the data register, and we are trying to read it. So we are going to provide the address as 8. Okay, yes. So is it clear? Any doubts or any queries in this? What about others? Is it clear? Waiting for your responses. So let me show you the output results which we are going to get over here. So I've applied my reset and I've removed my reset, and this is my P address which I'm driving it from my test bench. So here 4 means I'm trying to access my direction register. So the signal which is related to your direction register you can see over here. Okay. Now, before that, in our GPIO controller, if you remembered, we were having some states, right? So 0 is for idle state, 1 is for setup, and 2 is for access, right? So in the access phase, we are basically configuring the direction register if you have remembered the code. Let me show you the code also parallelly. So in the GPIO controller, in the access phase, sorry, someone was unmuted. Okay. So in my, where is my access phase? Yeah. So in my access phase, what I was doing, I'm basically accessing my data. Okay, so that is what it is happening. So if you want to get your direction register updated, you need to wait for the access phase. So this is what my access phase, and in the access phase, you can check over here. your GPIO direction register has been configured, and you're going to get FF over here. Okay. Since we were using non-blocking, so after this particular edge only, your direction register will be updated to FF. Okay. So since it has been updated over here, so the data which we want to write over, that will be updated. Let me show you. So you can see the expense over here. Where is it? Yeah. So you can see over here in the next axis phase, we are basically updating the address. Okay. Sorry, I mean the data. What is the data which we want to write is A. Okay. Let me show you in the test bench. So in the test bench, the data we are trying to write over here is A. Okay. So that we are writing it over here. You can see, right? So in the first phase of operation, after completing my access phase, direction register was set. Next, next you are providing the address as 00. That means you're trying to access the data register. So the data register to be configured, again you need to wait up to the access phase. After access phase has completed, then only your expense has been set. You can see over here. That means you need to wait for this many number of cycles to get your data to get into your expense. So let me explain you one more time. So first here you are providing the address as 4, and you need to have this idle phase, setup phase and access phase. After access phase has completed, then only your direction register has been updated. You can see over here. Now after direction register has been updated, then what you're going to do, again you're going to provide the address as 0. That means you are trying to access the data register. Now if your data register want to be updated, you need to wait up to idle phase, setup phase, and in the access phase your data register will be updated. That will be reflected into your expense. You can see A. This is what the master wants to write into my GPIO pins. So that is being written after this many number of cycles. Up to here, is it clear? The right operation, how your master is going into GPIO pins? Yes. Yes, Sampath. Yeah. Hmm. Yeah. Yes. 0 is idle, 1 is setup, and 2 is access. Yeah. Access. Exactly. So basically in your access phase, the registers we have seen right in the GPIO controller code. So whatever the registers you want to update, those particular things will be updated accordingly, according to your address which you have provided. If it is 0, you're going to access the data register, and if it is 4, you're going to access the address register. Sorry, direction register. Yeah, yeah. Next. So again, let's say if your master wants to read the data, so how it is going to read the data? It is going to first of all provide the it is going to first of all access the data register. How it is going to access it? So it is going to provide the particular address as 4. Then it is going to access the direction register. And again, we need to so see if you are going to where is it? Yeah, so this is my GPIO direction register that is being updated after the access phase has been completed over here. So the GPIO register has been updated, right? So that means 0 is nothing but now the GPIO pins are going to act as an input. That means your master wants to read the data. Now, how it is going to read the data? So using the PR data signal, it is going to read the data that we are going to add it. Let me add that PR data. Yeah, PR data is already present, and we are not able to read any data. Yeah, we can able to read. Let me show you. No, it is not being read. Why it is not being read? Okay, let me check it out. Why it is being not read in the top TB? Let me provide it 0 so that I can access it. Let me run it. Yeah. So I can read the data, that is AA. You can see from the test bench, you're going to give the data. Where is this data? You're basically providing AA rate. So that is being read using your PR data signal. Okay. Yes. So this is how you're going to provide or you're going to control your GPIO register using your APB interface signals, right? Yes. So that's about this particular working. So if you have any doubts or any other queries you wanted to discuss, you can discuss with me, or else we can wrap up our session over here. Okay. Yes. Thank you. Hope you have got a clear understanding of how the things are working.